Now, again, you can see that all these are meta directors, and this will be the most deactivated group. The ring will be most deactivated by this. Therefore, if you get the reactivities of these meta directors, this will give us the least reaction speed, or the rate of the reaction will be very least, because once again, remember that how you can identify whether the given group is meta director or orthopara director. Just you look at the bond, say you have this group, no matter whatever the R group means any alkyl group attached to benzene ring, it acts as orthopara director. And if you have any other group attached to that, like having lone pairs on that, say you have the CH2 here, the NH2, then you have lone pair on the atom which is directly attached to the benzene ring, in this case the nitrogen. And if you have the oxygen attached to that, again that oxygen may have a pair of electron, or just a single lone pair or more than one lone pairs, right? Then these are, or there are some other cases where it may not have the lone pairs, or it may not be such alkyl group, but still there may be some groups having what maybe like say Nigella, okay, like this. Then say just imagine that this oxygen does not have the lone pair. Still, you can identify this as orthopara director. How you can just polarize the bonds other than this carbon on the benzene ring. This is the 2.1. Electronegativity is 2.1 here, and the electronegativity is 3.5 here. Then this become delta minus and this become delta plus. So delta minus will be here. So that delta minus will direct the next coming group to the ortho or para position. So it is ortho para director. Just you can polarize the bond and check whether the direct attached atom gets a negative charge, partial negative charge, right? And so it will be like this. Then the other thing is, all these are we call the ring activating groups. But when halogen attached to benzene ring, like chlorine, because of the presence of lone pairs, it can uh, give electron towards the ring and can activate. But because of the high electronegativity of this, electron cloud of this benzene ring will be attracted towards the halogen atom and deactivate the benzene ring. But still, because of the presence of these lone pairs, it will direct the next coming group to the ortho or para position. Then remember that all the ring activating groups are ortho para directors. All these are ring activating groups here. Then all the ring activating groups are ortho para directors. But all the ring deactivating groups are not meta directors. There may be some ortho para directors like this halogen attached benzene ring. In this case, the ring will be deactivated, but still it is orthopara director. Still it is orthopara director. Right? Okay. Then, but all the meta directors here, all the meta directors as shown here are ring deactivating groups. All the meta directors are ring deactivating groups. But all the ring deactivating groups are not meta directors. There may be some cases or exceptions to that because of the halogen. And all the orthopara directors are ring deactivators, but all the ring deactivators are not meta directors. There may be some orthopara directors. The only example is that exception is this halide. Right? Okay. Now, the most deactivated group is that N group. As you can see here, this NR3 means you have three alkyl groups attached to this nitrogen atom, then it will be the most in this case. And according to this, the least. According to the given things here, this is the least deactivation. When the aldehyde group is attached to benzene ring, like this. And here, all the ring activators are orthopara directors, but all the orthopara directors direct in the species are no ring activators. Exception is that the halogen. All the meta-directing species are ring deactivators, but all the ring deactivating species are not orthopara directors. Again, the is halogen attached to benzene ring. The compounds which has the halogen attached to the benzene ring may be like that. Okay. Then you may try these conversions. You have all these conversions in the note I sent you today, right? You may try the first 5 questions. I'll give you 10 minutes to complete this first 5. Just try it. Okay, let's see one by one. First one. In the first case, the CH3 group and Br groups are considered. Those are meta to each other. Why? This is the ortho position, this is the meta position. If you get this as the first substituent, then again ortho and meta. That means meta to each other. Then whatever the group you add, first you have to add the meta director. Then the next group. Let's see. If you first add this, what do we need here? We have the CH3 group here and Br group here. Then, if you first add the CH3 group, you can add that CH3Cl and AlCl3. Then you will get the CH3 group attached to the benzene ring. And then you can try the next. Now we know that this group is orthopara director, but we need at the meta position. So then it will not work. Why? This can't direct the next group to the meta position. It can direct only to the ortho or para position. So that is not the way. Very simple. Then you may try with the BR case. Then you can add Br to ion. Then you will get Br added to this. Again, Br is halogen. Halogen may deactivate the benzene ring, but still it is orthopara director. So no, it will not work. Therefore, you have to go for an alternation. How? First, you have to anyhow add meta director. Then I will first add this CH3 group. Then I can turn the CH3 group into this group. Then you can attach the benzene, sorry, the Br group. No matter which corner this is attached, right? Why? Each and every corners are identical. If you put that here, even it's okay. Right? Now I put this here. And Br now will be attached to this position. Now you add Br to an Fe. Then you will get this Br here. And then you can remove the oxygen attached to this by adding Clemmensen reagent. It's a Den Hg conc HCl. Then here to here you can add CH3Cl, AlCl3, and CH3 to these. You can oxidize this to that. Add in MnO2, conc H2SO4. Then you will get this as a product, and now it is correct. And this is the way you have to follow. Anyhow, you have to first add the meta director and then the next group. Then later you can remove that meta group. Then try the next. Now try the others. Okay, the second one, this is okay, right? Right. Straight away you can add this first and then the BR. Let's try the next question. Here we have the benzene, and then you can turn that into this and BR here. First add this benzene ring and then add the BR. So here CH3COCl anhydrous AlCl3. Anhydrous AlCl3, then you will get this product and then the BR. This second one. Here you can add EBr3 and Br2. Earlier I had this iron and Br2, now FeBr3 and Br2 both are working in the same way. And the third one, just the extent of this third one. You have just extend this. You can now add to this just to get the third. Okay, I will do it like this. The third one. Again, if you first add this alkyl group, And then at Br will go to ortho para position. Again, if you first add the Br, then the next group will go to the ortho para position. Therefore, what you need to do is like this: CH2, CH3, and Br here. First, you can add the same thing as earlier to this. Now, this is a meta director. You can add Br to this, then Br will direct to the meta position by this group. And then you can remove this by adding Clemmensen reagent ZNHG concentrated. It's here. So here to here, you can add CH3, COCl, anhydrous, AlCl3. Then you will add FeBr2. Then you can add Isodane, Hg, conc HCl. Then you will get this product. The third one. Next, the fourth one. This is the third one. Then fourth one is this one, nitro to bromine. In this case, those are in para to each other. Let's move to the next, then fourth one. The fourth one. We have the benzene here. First, you have to add Br. Then add the nitro group. The nitro group now attached to the meta position. No matter whether it is in this way or the other way around, that means both are identical. If you write down the IUPAC names, then you will get the same name for both of these. See, doesn't matter. It is same compound. In this case, we no need the orientation of the molecule. We need only the position of the atoms or group. Now first you add Br, FeBr2, then you can add concentrated H2SO4 and HNO3 and 50 degrees Celsius. Then you will get this product. The fourth one. Then the fifth one. Okay, now let's see the fifth one. Go back. In this case, here the groups are ortho to each other. The fifth one. Straight away you can't add or convert benzene ring into benzoic acid. But here you can first add the Br2 and Fe. Then you will get this product. And then you can add this. It must be in ortho position. And then you can oxidize this to benzoic acid. Then finally you will get this product. Then here to here you can add CH3Cl, anhydrous AlCl3, and here to here you can add KMnO4H plus. Then you will get the product. If you first add the CH3 and convert that into the benzoic acid, then the next coming group will direct to the meta position or to the ortho para. Then try the next questions.